Good morning to you all. Today is our last lesson on the flood, and in today's lesson we're talking about how the flood reshaped the earth, reshaping the earth. Now last week we focused on the ark itself, why the ark was an amazingly perfect vessel for handling the flood. Using the long cubit, what were the dimensions of the ark in feet, if you remember? That's right, 510 feet long. How wide? 510 feet long. Not 51 feet wide, that's the other dimension. It is 85 feet wide and 51 feet high. So 510 feet long, 85 feet wide, 51 feet high. Now to put that in perspective, using American football, the length of the ark was about 1.5 football fields if you include the end zones. The width of the ark was about half the width of a football field. So think about the width of a football field. The ark would have been half of that. And then the height was about the same height of 3 goal posts stacked on top of each other. So if you think about those field goal posts at the end of a football field, imagine 3 of those stacked on top of each other and you have about the height of the ark. Here's another image comparing the ark's length and height to other ships. You see the Santa Maria from Christopher Columbus, the largest wooden ship ever built, the Wyoming, or rather the longest wooden ship ever built, the Titanic, and the Queen Mary II, which is a modern cruise liner. See the length of the ark compared to those ships, a very big vessel. The ark would have actually been the longest wooden vessel ever built. Now some today object to the accuracy of the flood account because they say the ark, as a giant wooden box, could not have weathered such a catastrophe. But as we discussed last week, there's good reason, first of all, to believe the ark was not a box. Why? Yeah, Rob. Well, boxes do float, but boxes, there's something about the flood that that a box would not handle very well. Yes, Roy. That's right. A box would not orient itself very well to wind and waves, and so it would keep getting slapped on the side and rocked violently, which would be dangerous for the inhabitants inside. So there's that reason for believing that it wasn't a box. Are there other reasons? Say that again, Bill. That's right. The Bible doesn't actually say that it's a box. The word for ark, used for the ark there in Genesis, we don't know the meaning of that word, but the closest meaning that we can probably come up with is lifeboat rather than box. Also, we certainly realize that not all the details of the ark are recorded in Genesis 6, where we get the ark description. Many details are recorded. Very accurate and fascinating details are recorded, like the dimensions of the ark, but nonetheless, not all of the details are recorded. Of the dimensions that are recorded, however, those are the dimensions of a ship that was designed to move through the water. If you simply were designing something to float, you wouldn't have used the dimensions, or at least from our thinking, you wouldn't have used the dimensions that the ark actually consisted of. So a number of reasons why we can say the ark was probably not a box. Now, God could have miraculously preserved a box-shaped ark, but we have good reason to believe that it was shaped like a ship. As an ancient ship, what were some likely features of the ark that made it perfect for enduring flood waters? What were some of the features? Yeah, Craig. That's right. It didn't leak because it used a special kind of planking system. Do you recall the planking system we think they used, Julie? Or no? Does anybody remember? Mortise and tenon planking. Very labor intensive. You have to, if you want the particular details about how that works, I'm afraid I can only point you to some articles because it does get pretty technical, but a very effective way of keeping the ark strong but also dry. Because large wooden vessels in modern times, they were notoriously leaky, but they used a very different method of planking. So we have mortise and tenon planking. What were some other features of the ark that made it strong against the flood? Say that again? Well, there was no sail, but there was something like a sail that would have been helpful. Why was it important to have something that would stick up? Yeah, Joe. That's right. So it wasn't necessarily on the bow. In Answers in Genesis version of the ark, it is on the bow, the front of the vessel. But somewhere on the ship, you probably have a obstruction, some kind of fin. It could have been a sail, but a sail would have been a little bit hard to maintain. Something that would catch the wind. And that's important because if you can catch the wind will push the ark and until the ark is moving in the direction of the wind, which means that the wind will no longer be battering the ark on the sides. It will be pushing the ark along through the waters, which is going to make the ride a lot more comfortable. Same thing for the water. We need something to catch the water, and so that's why there is probably a fixed rudder on the back of the ark, also called a skeg. Same concept. As the waves push against the ark, they're going to change the direction of the ark until the ark is moving in the direction of the waves. So it's a much safer, much more comfortable ride as it's being pushed by the winds and waves in the same direction that the waves and wind are going. These features are on ancient ships, and so it's not very much of a logical leap for us to suggest that they were also on Noah's Ark. Now, such an ark would definitely have been seaworthy and a testament to the great wisdom of God. Others object, however, to the ark on different grounds. They say even if seaworthy, the ark could not have contained all of the animal species of the world, especially the dinosaurs. Well, how can we respond to that objection? Yes, Joe? That's right. So for especially the big animals, there would have been some wisdom about how old and how big of a size the animal you would bring on the ark. Noah probably had younger, smaller versions of dinosaurs and some of the bigger animals on the earth, though not all animals are that big. The average size of an animal in the earth today is less than a sheep. But what else? What's another reason that we can say, well, your objection actually is groundless? Yes, George?
The Bible doesn't say bring every animal, it says every kind of animal.
Exactly. We're not supposed to bring, Noah was not instructed to bring of every species, but of every kind. So he wouldn't have taken tigers and lions and leopards. He would have just taken 2 cats, though probably the cat kind looked different than it does today. You probably didn't even have those variations. So the amount of animals he had to bring on the ark was much more manageable because he was only bringing of the kinds. And it was not difficult for Noah to, or let me ask it this way. Was it difficult for Noah to find and gather all these animals? That's right. The text is actually explicit. It says God will bring the animals. God brought the animals to Noah. So actually God was the one who was applying the wisdom, selecting which animals for Noah to bring on the ark, which age and which size, etc. So there was actually plenty of room on the ark for Noah, his family, and the animals, and of course, more people, those who would repent and be saved from the flood. So that's what we talked about last week. Any questions about the ark? Yes, Carol?
Didn't they have pitch put on the bottom?
That's right. There was pitch not only on the bottom, but inside and out of the ark. And that was part of what would keep the wood dry and keep it from flexing and keep water from coming inside. So yes, pitch was another important feature of the ark. Other questions? Okay. Well, a global violent flood would have needed a well-designed ark to endure it. However, a global violent flood would also have greatly impacted the geology and topography of our world. Over the centuries, scientists have observed many mysterious details in our planet's geology. For instance, you have sediment layers that are consistent across entire continents or large parts of continents. The same layers laid down in the same way. You also, in certain places, have folds in rock layers that surprisingly did not cause the rock layers to break. There's a smooth bend, a smooth fold, which is strange because you would expect that if there was something that forced the rock layers up violently, they would fracture. Also, continents appear to have fit together at one time. And then you also have marine fossils on high mountain peaks. So these are puzzles for geologists. How did these things come to be? Well, most secular scientists are going to give an answer based on what fundamental assumption? That's right, uniformitarianism. They will say something along the lines of, everything we see is the result of very slow processes over millions of years. They are the same processes that we observe today. But we know that something happened in the past that makes uniformitarianism a false assumption. What happened? the flood and creation. Two very non-natural, I guess you could say, supernatural events, certainly not like what we see today. For answering any geological question, one must take into account the Word of God. If you don't factor in creation and the flood when you're studying rocks, your interpretation is likely going to be faulty because you're starting with assumptions that are false. Once we factor in creation and the flood, however, we still are left with the question, how do we explain these puzzles? Yes, we know creation happened, we know the flood happened, but how did those things produce the geology that we see in our world? Now, even though sometimes we cannot say more than, God did it. I don't know how. God did it. Creationists, creation geologists, and creation scientists have come up with very plausible models, various models, to explain, in a way consistent with the Bible's details, why the world and its geology is the way that we see it today. So actually, in today's class, I want to present to you such a model. I want to present to you a geological model for explaining how the flood is responsible for the rock layers and the continental forms and positions that we see today. And this model is called Catastrophic Plate Tectonics. Catastrophic Plate Tectonics. It's a geological model, a theory. This isn't fact, but it's a model for explaining what we see. Now, this model was first proposed by Antonio Snyder, a creation geologist, in 1859, based on the scriptures and his observation that the continents looked like they once had fit together. They had once been connected. Snyder really should be the one credited with the first idea of continental drift, the idea that the continents move. But for whatever reason, history gives that honor to a different geologist, Alfred Wegener, a secular geologist who proposed that idea again in 1912. Even then, the theory was not very much accepted. It was only until scientific advances in the 1960s that the idea of continents moving, plate tectonics, really caught on. And the theory of continental drift has been refined very much since then. But we're talking about catastrophic plate tectonics, not slight movements, but huge, violent movements. And these were what caused the flood, and they explain how the world came about from the flood. While certainly not authoritative like Scripture, this model gives a reasonable explanation for where the waters of the flood came from, where they went after the flood, and why the world's rocks and continents look the way they do. The science of this topic can get a little dense, but let's do our best to see if we can get a basic grasp of this model and of its relevant concepts. Understanding this theory will be helpful for responding to certain skeptical questions, but also, hopefully, will fill us with awe. Fill us with awe at our powerful Creator who did judge the world and will judge the world. Let's pray. Ask God's blessing on this time. God, Lord, it is amazing as we discover more of your world through scientific observation. We see more of your great wisdom. We see more of your great power in creation. We recognize that our science and our scientific models are fallible, God, but we thank you that your word is infallible, and we want to base any of our ideas, any of our scientific interpretations from your word, and in a way consistent with your word. So God, I pray that you give me the ability to explain well this model, and I pray, God, that we would indeed be provoked to awe over you. In Jesus' name, amen. Let's start by reminding ourselves of just a couple of the details from the flood account. So open your Bibles to Genesis chapter 7. These details are going to be relevant for any geological model or any explaining model that has to do with the flood. Genesis 7, verses 10 to 12. Now, we've read through this passage before. I'm not going to take time to read it again this morning, but feel free to scan the text for a moment. What two sources of water are mentioned in the text for bringing the flood on the earth? That's right, we have the fountains of the great deep, and we have the floodgates of the sky. And we noted that these are figurative expressions, but what do they refer to? Yes, Danielle?
So it seems to be saying that if there's water sources from the sky,
That's right. So water sources from under the earth, probably in the oceans, because it says great deep, and that's a phrase in Hebrew that's always connected with oceans. So we have a water source from under the oceans, and we have a water source from the sky, probably rain. Now that seems plain enough, but what exactly is this oceanic water source? And where exactly did this rain come from? Well, let's see if we can get a little bit closer to answering that. Now there's a fair amount of debate. Let's talk about the rain first. There's a fair amount of debate on the nature of the flood's rain. Now some believe that there had been no rain on the earth up to this point. That with the flood, God caused rain to appear for the first time on the earth. Now there is some biblical support for this. Where can we go to in the Bible to support the idea there was no rain before the flood? Yes, Danielle.
In the beginning of Genesis, I think we read that it said something about God would water the earth with a mist.
Very good. Excellent observation, Danielle. You may remember from our earlier lessons, before the fall, we are told that there was no rain on the earth, but that God sent a mist, or a subterranean water source, to water the earth, or at least the Garden of Eden. So there was certainly no rain then. But what else can we say? That another reason to suggest there was no rain before the flood. Yeah, Julie.
Yeah, I mean, after the flood proceeded, there was the rainbow in the sky. Is that
Right. The rainbow would be very relevant because God says, I set my bow in the clouds. It's a reminder I'll never send the flood again. Now, rainbows are produced by rain. It's produced by water vapor in the air that refracts the light. Presumably, if there were rain before the flood, then there also would have been rainbows before the flood because rain produces rainbows. But it'd be strange for God to say, I'm making a new promise about the rainbow, even though the rainbow was there before the flood, but now, don't worry, I won't send another flood. That would be odd. The rainbows seem to be only something that were after the flood. Now, could God have produced rain without rainbows? Yes. But in terms of suggesting whether there was rain before the flood or not, it is another reason to think that there was not rain before the flood. However, there is one problem with this. If there was no rain before the flood, then why does God promise Adam in Genesis 3 that weeds were now going to flourish? Because as Danielle mentioned, Moses tells us in Genesis chapter 2, there was no rain on the earth, and therefore no plants that thrive with rain. You remember, we talked at some length about those two terms, plant of the field and shrub of the field. Shrub of the field meaning a weed. Weeds flourish in rain, irregular water source. Now, why would God say to Adam in chapter 3, thorns and thistles are now going to come from the ground. You're now going to have to be dealing with weeds. Things that produce weeds, rain, were not actually part of his experience. So, and there is some difficulty saying for sure whether there was rain before the flood. Another thing that we should keep in mind when thinking about the flood's rain, some also said that the rain was actually a special rain that came from a canopy of water that once surrounded the earth. So imagine the earth encased in this barrier of water. In the flood, then, God would have released this canopy of water, and it would have fallen as a massive torrent to the earth, very much like releasing floodgates in the sky. So there's this canopy of water that was above the earth, and God suddenly lets it go, and it all falls down. Now, this also has some support from the scriptures. It's partly based off of a statement that you may remember from Genesis 1. When God's describing the creation of the earth, what does he say that may suggest a canopy of water around the earth? Very good, Bill. So Genesis 1, 6-8, I'll reread that section for you. It says, Then God said, Let there be an expanse in the midst of the waters, and let it separate the waters from the waters. God made the expanse, separated the waters which were below the expanse from the waters which were above the expanse. And it was so. God called the expanse heaven, and there is evening and there is morning a second day. Now this statement has mystified biblical interpreters a bit over time, because where are the waters above the earth? We know the expanse is called heaven, or it's called sky, but what are the waters above the earth? And for this reason, some have suggested, well, there was actually a barrier of water, a canopy of water that surrounded the earth, and it was established at creation. This canopy is thought to have created unique conditions on the pre-flood Earth that promoted long lifespans. You may notice, or you may know, that after the flood, man's lifespans rapidly decline. And in this model, the idea is, well, with the canopy gone, you no longer have those life-sustaining conditions, those wonderful life-sustaining conditions. However, you may remember from previous classes I've mentioned to you, there are many scientific problems with a water canopy. It's hard to make any sort of model work that contains or uses a canopy of water around the Earth. The most notable problem is that the greenhouse effect in such a world with a canopy would have been out of control. Today, actually, when we think about the greenhouse effect, we hear about greenhouse gases and things that heat the Earth. But the gas that causes the most greenhouse effect today is water vapor. And it makes up the majority of our greenhouse gases. If we had a water canopy, the Earth would have been way too hot for anyone to survive. Now, it's possible that God had mechanisms in place with this water canopy that we simply don't know about, and he could have made it work. But we cannot say confidently that there was a water canopy, despite those verses in Genesis 1 that talk about the waters being separated. So I bring those up to you just so that we can keep them in mind. What I'm going to propose to you today about where the rains came from is based off of the model I mentioned, the catastrophic plate tectonics. There's a different idea about where the rains came from. And I want to introduce it to you by actually showing you a little video clip. This is from Answers in Genesis, a little reimagining of what the beginning of the flood was like. So it's a 2-minute video, flood initiation. And as you watch the video, pay attention to how the clouds form. You may be thinking that you're looking at tidal waves at first, but you're not. You're actually looking at massive, rapid cloud formation. So let's watch, and then I'll explain a little bit what we're seeing. Okay. So the video is a little intense, but the flood must have truly been a terrifying event. Now, as I said, you may have been thinking you were looking at a tidal wave the whole time, but no, those were clouds. In the video, what causes the clouds to form? Yeah, Julie. Exactly. So water vapor is caused by some sort of eruption in the ocean. It shoots into the air and immediately starts forming clouds, and those clouds quickly spread across the earth. What else do these eruptions cause? You may have noted, destroying the sailors at sea. That's right. So global magnitude tsunamis, you see a tidal wave that sweeps that boat away. With the splitting of the ocean there, we're looking at an earthquake or that causes a tidal wave. You may have also noticed that the Earth looks a little bit different. You can switch back to the presentation. the Earth looks a little bit different in the video. How does it look different? That's right. In the video, the Earth is just one continent, one solid landmass. So we're beginning to see some features of the model for catastrophic plate tectonics. Now let me explain this in a little bit more detail. What exactly is this model, and how does it suppose the flood took place? But before that, we need to review a little bit about tectonic plates. I don't know if you remember this from elementary school or whenever you study a little bit about geology, but you may remember. The outside of the Earth is made of what we call a crust, various moving plates of rock. It's what we live on. These plates don't move much today, but they do move, which is why we call them tectonic plates. Tectonic has to do with movement. Plate, it's the section of rock. They do move. Does anybody know about how far plates move per year? About 1 to 2 inches. Though different plates move at slightly different speeds, they only move about 1 to 2 inches per year. Now, their movement is responsible for what natural disasters? Earthquakes, and they're also part of volcanic activity. Their movement causes volcanic activity. Now, there are 7 or 8 major plates today. You can see that in the bottom right picture there. And depending on how you define the term, there are 7 to 8 major plates and a number of minor plates. And these are all plates. They are the crust, or they contain the Earth's crust. All of this crust, all of these plates, they float on an extremely hot, semi-fluid section of rock called the mantle. And you see that in the top left picture. You have the inner core, the outer core of the Earth, and then the mantle. And these plates, the crust of the Earth, floats on top of this mantle. Now, the mantle is rock, but it's really hot, and it has some fluid-like properties. The tectonic plates, they have 2 kinds of crust on them. There's continental and oceanic crust. And you can guess the difference. If it's in the ocean, it's oceanic crust. If it's continental, it's continental crust. Now, they're made up slightly differently. Slightly different kinds of rocks in those types of crust. Oceanic crust is thinner and denser than continental crust. So thinner, but more compact. It has a higher density of rock. So whenever a plate with an oceanic crust runs into a plate with continental crust, because the plates move, right? Sometimes they move towards each other. Whenever those 2 types of crust encounter one another, the plate with the oceanic crust goes under the plate with the continental crust. The plate with the oceanic crust actually starts sinking down back into the mantle. And it's going to melt there. It's going to disappear. This process is called subduction. Subduction. And you see a picture of that in the bottom left. The lost section of plate, the one that the oceanic crust, as it's going back into the mantle, it is immediately replaced on the other side of the plate by new material from the mantle that comes up and forms the new crust. Have you ever heard of a mid-ocean ridge? Mid-ocean ridges are mountain chains that formed on the ocean floor where 2 plates connect, or where 2 plates collide with each other. And it's at these sea ridges that new seafloor is generated. New material from the mantle comes up at these ridges, and it spreads ever so slowly to make up for the oceanic crust that disappeared back into the mantle. So you always have an ocean floor. Part of it, if it encounters continental crust, it disappears back into the mantle, while on the other side, new mantle material comes up and forms new seafloor. They call this seafloor spreading. And it's observable today, but again, it's very slow. With me so far? Okay. Now this is really relevant for the model I'm just about to explain to you. Before the flood, according to this theory, there was only one continent, which both secular and creationist geologists have a name for, and the name is Rodinia, which comes from the Russian Rodina, meaning motherland. Many creationists see biblical support, actually, for one landmass originally in Genesis 1:9. That's where God gathers the waters. I'll quote the verse for you. Genesis 1:9 says, then God said, "Let the waters below the heavens be gathered into one place, and let the dry land appear," and it was so. How does that show one landmass? Well, the thinking is this. The waters gathered into one place implies that the land was also gathered into one place, because otherwise the water would have to be gathered into several places. That's the thinking. So anyways, in this model, there was one original landmass, which we call Rodinia, and the flood began when the Earth's plates, the various plates on the Earth, violently split apart from one another in the ocean, opening massive ocean rifts. The flood begins when the plates, the Earth's tectonic plates, split in the ocean. And as the sections of oceanic crust moved away from one another, they moved towards the continental crust, right? And hot material from the mantle, where the plates moved apart, pours through the breach. We're going to get new seafloor, so hot mantle material, but a lot of hot mantle material pours through the breaches, and it pours through all over the Earth because all of the continents were splitting from one another. And so you have these opening of ocean rifts all over the Earth, and this hot mantle material, extremely hot mantle material, immediately vaporizes deep ocean water and sends it skyward. And this is what you saw in the video. The water shoots into the sky and quickly creates huge amounts of rain clouds. These rain clouds start to pour their contents onto the Earth, and more steam is ejected into the air as more mantle material is being pushed up where these rifts occurred, and therefore the rain keeps being reinforced. It therefore rains steadily and heavily over 40 days and 40 nights on the Earth, as the Bible says. So that's the idea of where the rain came from. But meanwhile, something is happening in the oceans. Something more is happening in the oceans. The splitting oceanic crusts, while being reinforced by the mantle, they are encountering the continental crust and are therefore being subducted. Ocean crust is more dense than continental crust, so it always goes underneath it. As the subducted plates dive into the mantle, however, they destabilize the upper mantle. And they cause this whole process of subduction to accelerate. And creationists call this runaway subduction. The subduction process begins to move faster and faster and faster and faster because the mantle becomes more and more destabilized. And as the crust moves faster, the mantle gets more destabilized, and it causes the crust to move faster and faster and faster until it accelerates to high speeds. And the whole process is moving like a conveyor belt. More and more oceanic crust is getting subducted underneath the continental crust. At top speed, well, just for comparison, the plates today move about 1 to 2 inches per year. But according to this runaway subduction model, which has been tested with sophisticated computer programs, the plates during the flood moved at about 1 to 2 meters per second. So today they move 1 to 2 inches per year, but then they were moving 1 to 2 meters per second because of this process of runaway subduction. And it wasn't just the oceanic crust that was moving, the continents themselves began to move because they too float on top of this mantle. The mantle is being destabilized. You have these currents of heat moving in the mantle, and they cause the crust on top of the mantle, the plates on top of the mantle, wherever they are, to move as well. So the Earth's continents also began to move at top speeds of about 1 to 2 meters per second. And so we get the breakup of this continent of Rodinia, and we're going to get these continents moving all over the place. As creationists like to say, this was no continental drift, it was continental sprint. These continents were moving very rapidly. The original continent, as I said, broke apart, and as the flood went on, these fragmented pieces would eventually collide together again. But at this point, the world was flooded. So you may see in the picture there, Rodinia, you can see the landmass, the original landmass. But in Pangaea, the whole Earth looks blue. Well, that's because these continents were colliding together, but underwater. And when sections of continental crust collide, they don't subduct. One doesn't go underneath the other. Usually, or rather, their crust is compressed and forced upward, forming what kind of landmass? Mountains. This is where we get many of our mountains. But by this time, while this continental collision is happening underneath the water, already the continents have new deposits on them, new sediment deposits on them. And within these deposits are creatures buried in the sediment. So therefore, as these new mountains were formed, what was already on top of the mountains? Fossils, especially marine fossils, because they were there. Those fossils were stuck in the sediment, And they were put all over these continents. And when the continents formed new mountains, the fossils that were already in the sediment, they just went to the top of those mountains, which explains why we find them there today. So those pieces collided with one another, but then they split apart again. They continued to move until they reached about today's present positions. And they took their new mountains with them. And we can actually see today some of the results of these continental collisions. You can see mountain chains that actually continue from one continent to the next, even though they're separated by an ocean. Just as you see in this picture, the Appalachian Mountains in North America actually continue right in a mountain chain with the British Isles and Scandinavia, the Caledonian Mountains. This is where those continents had collided during the flood when the tectonic plates were moving around, when they temporarily reformed a new continent, Pangaea. The continents, as I said, with some of their original landmass, were also given new layers of rock and sediment by the flood as the waters passed over them. So that's why the land masses, if we go back to the previous picture, the land masses they contain more sediment, more soil than they did originally, or they contain different soil. Some of the original continents would have sunk into the mantle. But anyways, so those continents moved to where they are today, or close to where they are today. But it wasn't just the rain falling all over the earth that was causing flooding. We do have the continents moving, and we do have the steam going into the air and causing massive rainfall. But the sea levels themselves were also rising. Well, why were the sea levels rising? It's not, at least in this model, it's not that water was being pumped through the Earth's crust. Rather, it's that the sea floor itself was rising. The sea floor itself was rising. Well, how could that be? Well, as I mentioned, oceanic crusts were quickly diving beneath sections of continental crust and entering the hot mantle. But you can't simply have no ocean floor. Hot rock from the mantle came through the gap left behind by these rifts, and they took over the ground of the retreating ocean crust. So just like today when we talk about subduction, whenever you have oceanic crust going beneath the continent, on the other side you have new crust being formed with hot material from the mantle. However, this was happening rapidly, and hot mantle rock is less dense than cold ocean crust rock, which means that the new hot ocean floor was going to float higher on the mantle than the previous cold ocean floor. Okay, that may sound a little bit confusing. I'll say it again and then I'll explain it with an analogy. Because hot mantle rock was rapidly replacing the ocean crust floor, and this hot mantle rock is less dense than the previous floor of cold crust rock, that means the new ocean floor was going to float higher on the mantle than the previous cold ocean floor. Now, how could that be? Well, let me explain using aluminum foil. Think about aluminum foil. If you take a sheet of aluminum foil, crumple it into a ball, and drop it into water, what happens to it? Wait, what? It sinks. No, it doesn't float. Aluminum, it is a pretty light metal, but if you crumple it into a ball, it sinks. If you don't believe me, you can try it at home. Now, why does an aluminum ball sink? It does have to do with gravity, but it's more than that. Exactly. This is what we talk about with buoyancy, right? The density of aluminum, the compactness of aluminum, is higher than the density of water. Therefore, it sinks in water. And if you crumple aluminum into a ball, you have that high density. However, if you take the same size sheet of aluminum and form it into a raft shape with upturned sides, and then put it in water, what happens to it? It floats, like that little picture down there. But it's aluminum, right? It weighs the same amount. It has the same mass as your crumpled ball. Why does the aluminum raft float? Well, the upturned sides, yeah, they prevent water from getting into the boat. But it's not really just about the shape, or not simply about the sides. Exactly. That's right. It's still about density. It's about density. The density is much lower in your aluminum raft. Because what is filling the space of your object besides aluminum? Air. And air is much less dense than water. And this is why heavy steel ships can nonetheless float on water. It's because they contain a lot in their space that is not heavier than water. They contain air and they contain other things that are less dense than water. Now, I'm going to relate this back to what we we're just talking about in just a moment. But 2 more points. As long as an object's density is less than water's density, what will that object do when it encounters water? It will always float. As long as the density is less than water, it will continue to float, unless something changes its density and makes it heavier, or it makes it more dense than water. But let's say we have 2 objects, one that is half the density of water and one that is a quarter of the density of water. Both of the objects will float, but what will be the difference in how they float? One of them is going to float higher on the water. Which one? The less dense material, right? They'll both float, but one will float higher on the water, and it's the one with the less density. Now, let's take that back to what I was just saying about the mantle. I said earlier that all the tectonic plates float on top of the Earth's mantle, but when a plate's crust becomes replaced by another set of crust that is less dense, is the plate going to float higher on the mantle or lower on the mantle? It's going to float higher. It's the same concept. We now have a less dense ocean floor, and it's already floating on the mantle, but because its density is less compared to the previous set of crust, that crust is now going to float higher on the mantle. So the new oceanic floor is higher on the mantle, meaning that the water above this ocean floor has to go where? It has to go up and has to go towards the continents. Because if the seafloor is moving up, well, then the sea level has to move up. Now imagine today if all the ocean's floor everywhere suddenly went up by about, 20 meters. What would happen? Massive floods. Tsunamis too, but massive floods. That is a lot of water being pushed up, and it has to go somewhere. In one of the web articles from Answers in Genesis, the author mentions a poignant fact. If you were to level out the Earth's terrain, if you raise the ocean basins and lower the mountains on the continents, do you know what you get? You get the world entirely covered by water. We already know that our world is mostly water. 75% of our world is water. God didn't actually need to pump new water on the earth to flood everything. All he had to do was raise the seafloor. And that's exactly what massive plate movement would do. Because the hot mantle material would replace the surface of the ocean floor, and if it was done rapidly, and hot material is going to be less dense, and therefore the seafloor is going to rise. So that's the idea of where the water came from in this catastrophic plate tectonic model. You have steam going into the air and causing rain, but you also have the seafloor rising, which is going to cause flooding all over the earth. But as we were just saying, tectonic plate activity would have also produced tsunamis, because what always happens whenever you have the plates moving from each other or encountering one another? Earthquakes. And you have earthquakes in water or volcanic activity in water, you get tsunamis, you get tidal waves. And these plates were moving continually, or at least for a good portion of the flood. So that would have produced tsunami after tsunami, wave after wave surging towards the continents. There's no way a person or a creature could have just floated through the rising waters if they were already on a boat. You may say, well, couldn't they have just survived the flood? No, not with the tidal waves that were continually coming at the continents. Any craft not specifically prepared for the flood would have been destroyed. And moreover, the ark was prepared for the flood, and it was probably built away from the coast. So the tsunami waves would not have devastated it like it would other crafts that were already at sea. So no other boats would have survived the flood. So during the flood, according to this model, massive plate movement caused rising sea levels, tidal waves, and torrential rain. And the surging of these waters over the land picked up a lot of rock and sediment, and they deposited it on the land. And of course, they buried many creatures when they did so, even creatures that were mid-bite or mid-birth. We actually see both of those in the fossil record. That must have been a very rapid burial. eventually all this chaos comes to an end. Because what must have eventually happened to the hot seafloor that would have caused the waters to recede? It will cool, right? That's what heat does. Heat constantly dissipates. It constantly transfers itself. And so this hot seafloor would eventually cool because the heat was being transferred into the water in other places. And so it cools and forms new ocean crust, and its density increases. Therefore, if the oceanic crust density increases, it's going to sink back down a little bit more on the mantle, meaning the seafloor levels sink, and consequently, the sea levels sink. So as the ocean floor cooled, the sea level would go back down. Eventually, the oceanic plates, not the oceanic plates, the oceanic crust would finish subducting. The plates would stop moving towards the continents. The oceanic crust had totally disappeared into the mantle. And so that runaway subduction came to an end, and therefore the continental movement greatly slowed or stopped. And with no more hot mantle material pouring into the ocean, because that process of runaway subduction was greatly slowed and came to a stop, the steam fountains that were constantly pouring water into the air, they too ceased. The waters all over the earth then were flowing back into the oceans. The sea level was going down, the ocean basins had become deeper once again, and the rain had stopped. So all that water is going to try and find its way back to the ocean. It's going to keep on going down the topography to get back into the ocean. And as they did so, what are the waters going to do? They're going to erode the surface of the land. They're going to carry a lot of that sediment, and they're going to carry part of the earth back into the water. And some of the water, though, is going to get trapped because we have new topography on the earth. There are already some hills and mountains before the flood, but there are also new mountains and new pieces of topography after the flood. So some water becomes trapped into higher elevations, forming large lakes. But water continues to exert pressure, especially on this new soft material, and some of it is going to burst the boundaries of those lakes. And it's going to rapidly rush towards the ocean. And when you have water that bursts its boundaries and starts moving through soft sediment and rock, what's that water going to create? It's going to carve that soft rock. It's going to start creating canyons and valleys. Secular geologists, they also suppose that water carves canyons and valleys, but they say it's just a little bit of water over a long period of time. But we're saying the opposite of that. It was a lot of water over a little bit of time. Now, some oceanic creatures would have gotten caught in the lakes, either the lakes that made their way back into the ocean or the lakes that didn't, and they just made a new life of it. That's where we got the creatures that lived in our lakes. They just made it their new home. So I think that pretty much covers the basics of catastrophic plate tectonics, but let me summarize. What happened during the flood according to this model? Well, it's all about the tectonic plates shifting. They split apart in the oceans. They caused massive amounts of steam to pour into the air. This steam condensed to create 40 days and nights of rain. The new hot seafloor, it caused the ocean levels to rise, and lots of seismic activity. The seismic activity caused continual tsunamis all over the earth, and all of this continental and all this plate movement caused the continents to move, to sprint to and away from one another, to collide with one another, and to create new mountain chains. Surging waters across the land deposited many layers of rock and sediment, burying plants and animals, and the receding waters caused large amounts of erosion and carved out many canyons and valleys. So, if this is the way the Lord did it, no matter the way he did it, it was a titanic calamity. The whole earth was put into an upheaval. And it is a reminder of what the scriptures say. It is a fearful thing to fall into the hands of the living God. That's Hebrews 10:31. The psalmist, too, was in awe of God's power in the flood. Turn over to Psalm 104 for a second. Psalm 104, verses 5 to 9. This psalm is a meditation it's a meditation on God's power and God's goodness. Part of the meditation is on what God did in the past, in creation, and in the flood. And part of the meditation is about what God does in the present to sustain life. And the section that we're going to be looking at is about what God did in the past. Look starting at verse 5, and we'll read down to verse 9. Psalm 104. Verse 5, He established the earth upon its foundations so that it will not totter forever and ever. You covered it with the deep as with a garment. The waters were standing above the mountains. At your rebuke they fled. At the sound of your thunder they hurried away. The mountains rose, the valleys sank down to the place which you established for them. You set a boundary that they may not pass over, so that they will not return to cover the earth. I think the psalmist was thinking about the same things that we're talking about today. The flood reshaped the earth. Now, can we say that this is for sure the way that God did it? Can we say we know that it was catastrophic plate tectonics? Well, no, we can't. We certainly can't say it like we can the Bible. We can't hold to it like we do the things in the Bible. But the reason I present this to you is because it's an example of what we should be doing when it comes to science. We start with the Bible and then look at what we observe today and propose a model that makes sense. And that's what catastrophic plate tectonics does. Now, I'm sure that there are imperfections in the model, but it makes a lot of sense. And if you want to hear more of the details, definitely go to answersingenesis.org. There's plenty of articles, some of them really technical, but some of them not so technical. Plenty of articles that can talk about those different aspects. Now, you may have questions now, and I'd like to hear them and answer them. Hold on one second, though. I want to show you one other short video, and then I'll get to your questions. This is a video that talks a little bit about how the rock layers and fossils are best explained when you start from a global perspective of the flood. And it ties into some of what I already shared with you. So if we could load up the video on rock layers. It's about 4 minutes.
Rock layers are visible in mountains, plateaus, and canyons all over the world. Where did these rock layers come from? Present processes aren't the answer. Today, sand and mud are usually deposited in thin layers along the outer edge of continents. And the formation of fossils today is rare. But somehow in the past, thick layers of sand and mud were spread across entire continents and filled with well-preserved fossils. Noah's flood suggests a way to explain these puzzling features. Flooding the continents, for example, could carry sea creatures many hundreds of feet above present sea level. Andrew Snelling is a PhD geologist from Australia who has spent over 30 years studying rocks, working in the field and in the lab.
We find marine creatures buried at the top of the Grand Canyon, which is over a mile above sea level.
A global flood could carry sand and mud enormous distances.
Some of the sand grains that are in the Navajo sandstone had to have come from the Appalachians. But what river or what process today is carrying material from the Appalachians to the southwest?
A global flood could quickly lay down thick layers of mud and sand, burying even giant animals and tall trees.
We've got coal beds with trees sitting on them, and these trees, tree stumps, go through many strata, which means that before they could rot, you had to have lots of sand and mud coming in quickly. Several places in the Grand Canyon, 4,000 feet of different types of sand and mud and lime have been bent, and they've been bent while they're still soft. Both the bottom layer and the top layer are all bent the same way, which means that the whole sequence of 4,000 feet of sand and mud and lime had to have been laid down very quickly by the waters and then bent very soon afterwards.
A global flood could form thick layers across entire continents.
In the Grand Canyon area, we've got limestone bed, the red wall limestone. The same limestone can be found over here in the eastern United States.
A global flood could cut deeply and widely.
We've got this huge flat surface at the rim of the Grand Canyon, which goes for thousands of square miles, where waters on a great scale over a vast area just swept over it and swept everything clean.
None of these processes, deep, wide erosion, or thick, rapid layering, or continent-wide distribution, or lifting of marine organisms above sea level, or sand carried across continents occur in the present. Radically different processes are required, such as occurred during Noah's flood.
Okay, so that's just a sampling of some of the geology that begins to make a little bit more sense once you factor the flood in. Now, does the flood explain every single thing that we see in the geology? No, of course not. But it is something that plays a huge role in what we see in the geological record. All right, let me hear some questions. Yeah, Danielle.
I'm just curious, do the interest in Genesis, I guess the scientists, do they talk about why we don't see human fossils with other fossils?
Yes, there's actually, I think, 1 or 2 articles that address that specifically. I'm trying to recall what the argument is. I can't remember exactly, but I know one of the things that they say is that there are a lot of assumptions that we may make about humans and human fossils that aren't necessarily true. Like we might think, well, why aren't humans buried with animals? Well, humans today don't usually live right with animals. We live separately, and humans may have been trying to do different things during the flood than animals would have, so that they didn't become subject to the same rapid burial processes that the animals did. It's also possible that there are sections of, or there are more larger sections of human fossils that we simply haven't discovered yet. Basically, there are a lot of unanswered questions when it comes to why, or there are a lot of things that we don't know about that would factor into the question of why we don't find that many human fossils and why we don't find them usually buried with other animals. We do find some human fossils, and of course they are the subject of intense scrutiny today, and that's where we get a lot of the inferences about the transition states between apes and man and things like that. But I would point you to a better answer would be from Answers in Genesis. Other questions? Yeah, Roy.
If you consider the distances, I mean, if you thinking of the Earth in the eastern and western hemispheres, the distances that are between the continents now, say Africa and North America, distances 3,000 miles, sometimes plus. Have creation scientists made any estimates of how long the duration of continental sprint how long that would take that sprint would go on to separate the continents that far?
Yes, I didn't, in my preparation for today's class, I didn't look for that number specifically, but one of the reasons why this model is held to by Answers in Genesis is because of the complex computer modeling by a guy named Dr. Baumgartner and I think some of the other creation geologists, where they basically simulated the conditions of the Earth and were looking to see, would you get the continental sprint that we think might have happened? And you do get it. And I'm sure that from that model, they can say, well, this is how long that process would have taken place. And this is when that process would have stopped. Now, I couldn't get access to that video model. I saw some presentations that were based on that model, but I didn't actually have access to the model itself. That's a good question, though. Other questions? Yeah, Steve.
Outside of the promise that God made with the rainbow to not flood the earth again, what's preventing this from happening again?
Yeah, that's a great question, Steve. Outside of God's promise, is there anything that we can point to scientifically that's preventing this from happening again? And I don't think we can. I don't think conceivably, if there was rapid plate tectonics again, catastrophic plate tectonics, then it would flood the Earth again. But
we still got the plates surfing on the lake of lava.
That's right. Yeah. So it would really only simply be God's mercy in that He keeps the plates from moving more rapidly than they do. I do remember that one of the articles, or a number of the articles that I read, talked about today's tectonic activity and volcanic activity are really just leftovers from the flood. That it's kind of like these are dim reminders of what happened then. And if you ask, well, what was the mechanism that triggered the flood? Was it a buildup of certain gases in the earth? Did something hit the earth from outer space? It could have been those things, but it could simply have been the finger of God where he says, you're going to crack now. And then that initiated the seismic calamity. Other questions? Yeah, Andrew.
Well, just as a point for Steve's question, I think modern day, what they're saying is most tectonic plate shifts happen because of that outer core movement around the inner core.
Okay.
Causes most, what they're saying is now, like the tectonics and volcanic activity that's happening right now, and that constitutes the movement of everything, so that in turn shifts the mantle around enough so that things happen.
Okay.
And so it's the amount of kinetic energy versus potential energy along the surface compared to the outer core circulating over around the inner core.
Okay. So just to repeat your comment, Andrew, that from what we can tell today, the reason that the plates move has to do with the movement of the outer core inside the Earth as it interacts with the mantle and causes the mantle to move, to change a little bit, and that causes the plates to move slightly. Now, certainly you might be realizing, or maybe you're asking, like, well, how do they know this? How do they know the mantle is moving, the outer core is moving? Because we're not anywhere near those sections of the Earth. Certainly, that is something that we have to factor in. We are kind of looking from a distance about what's going on inside the Earth, but through various kinds of measurements and studies, they can make some interpretation of what's going on inside the Earth. If you have some more questions, feel free to bring them up afterwards. We're out of time today. This is our last lesson on the flood. Once again, there's many more questions that are related to the flood that I'm sure you have or that you've heard or maybe will hear. Don't feel bad if you don't know the answer. It's totally fine for you to say to someone, I'm not sure, but here's a great place you can go. Or I'm not sure, I'd like to do a little bit more research and get back to you. That's actually a gesture of sincerity. I think that would be really helpful. But we, hopefully today and from the other flood lessons, gotten the basic knowledge so we can answer some of the common skeptical questions when it comes to the flood. But you can find more answers in genesis.org. You can come talk with me afterwards. We have one more week with our memory verse. We'll have to skip the application to questions, but I'll show you the memory verse once again. And then we'll get a new memory verse next week. Somehow disconnected. Let me try that again. There it is. Maybe you've memorized it already. I was going to recite it today, but we're out of time. We'll do that in next class, and we'll get our new memory verse. Next week, though, we move on to our next C in the 7 C's, confusion. Confusion at Babel, because that only takes place about 100 years after the flood. Let's close in prayer. Lord God, we are in awe at your power, God. You are in total control of the earth. And Lord, it is only by your mercy that these plates don't go out of control today. And Lord, that the earth is not flooded once again. But Lord, you keep your promises, and the rainbow is a reminder of that. God, we thank you for your gospel. We thank you that there is good news, that you are not simply the powerful judge, but that you made a way. You made a way for us to know you and be reconciled to you. Thank you, Lord God. Bless the rest of the service today. Amen.